Hey guys, lesson today, talking about rules of exponents. So when we're dealing with whether it's variables or whether we're dealing with numbers with exponents, there are certain rules that what we can do here. And specifically when we're talking about when we're multiplying or when we're dividing. Okay, so whether it's multiplication or division today. So I want us to look at this. If I'm doing this first one here, a to the fourth power times a to the third power. Let's think about what that means there. Okay, a to the fourth power means if I took a times a times a times a, there are four of them. So a to the fourth power is really all of this right here. That's a to the fourth power. But then it says here that we're multiplying times a to the third power. So if I multiply now this a to the third power, let's write over here, a to the third power is a times a times a. Now, if I have this entire thing being multiplied together, which is really just 7 a's being multiplied, a times a times a times a times a times a times a. Well, simplify that. How many a's do I have being multiplied together? We have 7 of them. So we end up having a to the 7th. So our rule is really this. Because our base on these powers are the same, meaning they're both a's, and they're being multiplied together, the rule is if you're multiplying powers with the same base, in this case the same base, they're both a's, then you're simply going to add the exponents together. So the exponents 4 plus 3 is what gives me that 7. Okay? So again, when multiplying powers with the same base, we keep that base, that's why it's still an a, and we add the exponents. 4 plus 3 gives us 7. Now, on the other hand, a over 5 divided by a over 2, okay, if we look at that for a second, well, let's write a to the 5th out. A times a times a times a times a, where there are 5 of them in the numerator. On the bottom is a to the 2nd, so that's a times a. And then what we would do is anything in the numerator cancels with anything in the denominator. That's the same. So these a's slash kill each other, cancel out. Another pair of a's slash kill each other and cancel out. So what we end up here is in the numerator we're left with 3a. So a times a times a is a to the 3rd. And on the bottom, all the a's are gone, but it doesn't become a 0, because remember, there's always a 1 there. So this becomes a to the 3rd over 1, and then anything that's just over 1 can be simplified to just a to the 3rd. Okay, bringing us back to our rule. When dividing, okay, let's go to the top again. When multiplying, we added the exponents together. When we're dividing here, we're going to subtract the exponents. 5 minus 2 gives me, that's how I got the a to the 3rd. And because a to the 5th was in the numerator, which meant there are more in the numerator, because the exponent's bigger, that's how the a to the 3rd ended up in the numerator. If this was reversed and it was a to the 2nd over a to the 5th, where the bigger numbers on bottom, well then, since we'd still do 5 minus 2 gives us an a to the 3rd, but then it'd be the a to the 3rd in the denominator, if that was the problem. Okay. All right, here's the rule actually written down. So rule, when multiplying powers with the same base, we add the exponents. So I'm going to do we're going to do example 1. Okay. Example 1, part A, and I'll do this first one for you, and then I'll let you do B and C. So part A, first of all, you have to make sure they're the same base. So they are both 2's, so my answer is going to have 2 as the base. It's a multiplication, so I add the exponents. 5 plus 2 in the exponent gives me an exponent of 5. Okay, so 2 to the 5th power. So what it's basically asking us to do here, if we're multiplying those, is just add the exponents together. Now, if the question actually said to simplify this, or I'm sorry, not simplify, if they asked us to solve the problem, if they actually wanted an exact answer, then we would actually figure it out. 2 times 2 times 2 times 2 times 2, and we'd get that final answer, which would be 32. Okay? You guys go ahead and try part B, and again, I only want you to keep it with a base and an exponent. Okay, so pause the video, do B and C. Okay, you're back. So again, same bases, so that stays an 8. Since it's a multiplication, the rule is when multiplying powers with the same base, we add the exponents. So 7 plus 5 gives me 12. So that's 8 to the 12th power, and thank goodness we don't actually have to figure that out, because that'd be a really large number. All they want us to do right now is practice this new rule with the exponents. Okay, part C, 5 times 5 to the 2nd power. Hopefully we all remember this first 5 here, even though there's no exponent, we should know that there's always an exponent of a 1 if nothing's showing. So now when I say my bases are the same, so it's going to be 5 to some power, I have to add the 1 plus 2, which gives me 5 to the third power. Okay? Example 2, go ahead, try part A on your own. Shouldn't be any different with variables. Okay, so we're back. X to the 6th times x to the 9th. Since my bases this time are x, that means they're the same, so the base stays in x. Numerators, 6 plus 9 gives me 15. X to the 15th power. Now part B is a little more tricky here, just because we do have some coefficients involved here too. So the first thing I want to look at is just look at the things with the same base, which would be the x here and the x to the 5th. Well, that's no different. This is x to the 1st power times x to the 5th power. So what I want to do is use our rule for those two things because they have the same base. X to the 1st times x to the 5th gives me x to the 6th power. Now when it comes to the coefficients, they're not the same base. 3 and 5 are not the same, so I don't do anything with their exponents. But since it is a multiplication, I can just multiply those together. 3 times 5 gives me 15. So final answer, 15x to the 6th power. Okay, then we have our dividing. So again, back on page 1, we talked about a rule for dividing, which I now have written down here. It says when dividing powers with the same base, we subtract the exponents. So remember, it's like doing this. If I have 7 to the 6th, it's like having 6 of the 7s on top and then 2 of them on the bottom. And what we would do is we cancel the ones out. So those 7s cancel, these 7s cancel, and you say what's left. Well, on top, I have 7 4s left. On the bottom, I don't have anything, so that's just a 1, and we get 7 to the 4th power. But our rule, the shortcut is this. We say, okay, the bases are the same, meaning they both have a 7. Okay, the exponents is a 6 and a 2, so we have to do 6 minus 2, which is what gives me the exponent of a 4 right here. Okay, so the base stays the same, 7 to the 4th power, because 6 minus 2 is 4, and I kept the numerator on top here because in our original problem, the one with the biggest exponent was on top. So that's how I know there's going to be more of them on top. So when they cancel out, the ones that are left on top. Okay, part B. Okay, same as always here. So if we look just at our variables and exponents, okay, if that was the problem, was x to the 8th over x to the 2nd power, we'd say where are there more x's? Well, there's more x's on top, so that's where the x's are going to be. But then we have to do 8 minus 2, so we subtract our exponents and get 6. So there are 6 of them left on top. Now when it comes to the actual coefficients, the 4/10ths, reduce that just like a fraction. I know 4 and 10 can both be divided by 2. So 4 divided by 2 is 2. 10 divided by 2 is 5. And all I'm going to do is take those new numbers and write those right where they are. The 2's in the numerator, the 5's in the denominator. There's nothing else in the denominator because that x to the 2nd got canceled out. So you get 2x to the 6th power over 5th. Last problem of the day. So a little more tricky one here. So a couple ways to do this, and I'm going to let you do it. But my hint is this. Do everything in the numerator first, then go ahead and worry about the denominator. Okay? Then worry about the denominator. Okay, pause the video. Give it a try. Okay, we're back. So if I'm looking at just the numerator here first, let's use our rule. Our rule says this, okay? I have an m to the 5th power and then times m to the 2nd power. With the same bases, it's going to give me an m, and then I add the 5 plus 2 because they're exponents, and that gives me an m to the 7th. Now the coefficient is a 3, and the coefficient on the m to the 2nd is a 1. Okay, 3 times 1 gives me 3. So I get 3m to the 7th on top. I still have this 6m to the 3rd on bottom. Now it's more simplified, okay? So now we change rules. So on the numerator we use our rule for multiplication, and now I have to use my rule for division. So I have my m's here, okay? 7 minus 3 gives me an m to the 4th, which I'm going to put on top. You know what? I'm going to write this down below a little bit here. I'm going to write this m to the 4th, which I'm going to put in the numerator because there are more m's in the numerator, okay? And then the 3/6 cancels out and becomes a 1/2. So I end up with 1 over 2. And if we want here, we can even get rid of this 1 right here and just make it m to the 4th over 2. That's it, guys. That's our rules for exponents.